Hi YouTubers. We're studying, I'm using a DC power supply, of course. 3.33 volts right now at a constant current application of 420 or so milliamps, plus or minus 0.01 milliamp. We have a simple breadboard setup circuit, and we're running a small DC motor. So our power output to the motor is within acceptable limits. We don't have a resistor in there. However, we have in there graphite felt. And this commercially available graphite felt has, of course, a degree of conductivity, and it has surface area. We would use it in supercap electrode applications, but we want to see how it does here without solvent, without electrolyte, just the properties of the graphite after it's been in a circuit at a modest, right now, a little less than half an amp. And we're going to run this, and then with scanning electron microscope, we will look for 10,000 to 50,000 magnification, any changes in the surface. And what's interesting, though, we're going to apply pressure. I have the graphite right now in a small plastic capsule, but I'll be putting it in shrink wrap, and we will apply pressure to it, hysteresis applications, just to get a feel on how the current of the circuit will change with application of pressure. And then when we remove the pressure to the graphite felt, if there are any noticeable changes, and we'll have an oscilloscope set up as well, but we're going to be comparing the graphite felt to a carbon fiber felt, which is a lot cheaper to produce. It requires 1,000 degrees Celsius versus 2,000 degrees Celsius for graphite. And the carbon fiber felt will have a degree of conductivity and surface area. We measured with a multimeter the ohms resistance of this graphite. This is without nickel deposition, and it was down around 5 ohms per centimeter, which obviously you can see it's conducting for this setup. We will also be nickel plating copper and iron electroplating on the surface of the felt, and get a trade-off between boosting conductivity but not coating it so much that we lose the surface area for electrode application in supercaps. But what's nice is this preliminary and simple test can be done with undergrads. Maybe you have a class with 10 or 15 students. This is something where they can do electrochemical deposition of copper, iron, cobalt, nickel, and see the performance. So right now we're at 3.44 volts and constant current of about 420 milliamps. And we'll let this run for 10-12 hours and begin to study the surface of it. But a very good introduction to energy storage and electronics, where students can vary what it is they're investigating and compare their results with others in the class. It's also very good for home researchers at home, and it doesn't cost a heck of a lot of money to do this type of study. The clamps there for current collection are small stainless steel clamps that I found in the crafts section at Walmart. I'll keep you posted on results. Thank you much. Thanks for watching. Bye for now.